In this video, we're going to talk about geometric sequences. What makes a sequence geometric is that we multiply by a fixed amount, a non-zero fixed amount, which we call the common ratio between each term. So it is a non-linear pattern, which makes it different than an arithmetic sequence. So the recursive formula here, instead of adding our ratio, we multiply. Hence why it's multiplication. And we multiply the common ratio by the previous term to get the next term. So there's a formula to find any term in a geometric sequence, and it is this one right here. We have a base n equals a1, which is our first term, times the common ratio and the n minus 1 power of that ratio. So let's find the 11th term of this sequence. So I'm going to start by writing out my equation here. Alright, so I know that I'm looking for a base 11. I have my first term, and that's going to be multiplied by the common ratio. And the way that I find that is I take any two terms and I divide the second by the first. So for example, I would take negative 1/2 and I would divide that by 1, and that's a nice negative 1/2. So I'm going to put that in here. And I bring that all to the power of n minus 1, so we're looking for the 11th, that's 11 minus 1. I'm going to work that out. So what I end up with is the 11th term is 1 over 1024, which makes sense because I am going to be multiplying by negative 1/2 for each term that I have. So it's going to be pretty small. And just like with an arithmetic sequence or series, I can find the sum of a geometric sequence or series. So it's a little bit different than the arithmetic, but it's essentially the same information. So we're going to take the first term and we're going to multiply it by 1 minus r to the n. So that means that I take whatever term that I am looking for. So if it's the sum of the first 11 terms or nth terms, I put that number there and I use the r to be the common ratio, and that's all over 1 minus just the common ratio. So let's take a look at this example. So I want to find the sum of 1/2 plus 1/4 plus 1/8 plus etc. to 1/2 to the nth. So I know that my sum is going to have an n in it. And really all I have to do is plug in my information here. So my first term is 1/2. I'm going to do 1 minus our 1/2 to the n all over 1 minus 1/2. So I know my common ratio is 1/2 because I have 1/4 all over 1/2. If I multiply that by 2 over 1, that's going to cancel. I get 2/4, which is 1/2. Or I can just look at it and know that I'm multiplying by 1/2 each time. So I'm going to simplify my sum over here. So I chose to simplify that first, make that 1/2, multiply by 2 over 1 and top and bottom. That cancels here and here, which just leaves me with my sum of 1 minus the quantity of 1/2 to the power of n. And I can also find the sum of any finite series, and I would just change that n to whatever number it is that I'm looking for, and that would give me the new sum. Something new that we haven't seen with series yet that pertains specifically to geometric series is this idea of something being convergent versus divergent. So in general, when we talk about something being convergent, that means that it approaches something. And if something is divergent, it goes away from. So in mathematics, when we talk about a series, if I'm adding up all these terms in a geometric series where it has a common ratio where I'm multiplying each time and it's non-linear, right? It's going to have some kind of curve to it. That means that it can approach a number. So if I have a sum that approaches a number, then that's called convergent. So we use this summation notation here. And if my sum, so it has to be a finite sum. It has to be a certain number of terms. It can't go on to like n or infinity. Then if it does not approach a certain number, if the sum does not approach a certain number, it is called divergent. So the easiest way to check this, especially if you're given this or if you can find the common ratio, is to check the absolute value of that number. So if your common ratio, if the absolute value of it is less than 1, it converges. You can find the sum. If the absolute value of your common ratio is greater than or equal to 1, it diverges, which means that you can't find the sum of that series. So let's take a look at two examples. This first one down here, if I'm looking at this whole expression, I'm only going to be checking out the r, which is this part right here, which is my 1/3. So if I take the absolute value of 1/3, that gives me 1/3, and that's less than 1. So that means that that series converges. So if I look at this other example here, I'm only going to be looking for r. I have 3/2. If I take the absolute value of 3/2, that gives me 3/2, and that's greater than 1. So that means that that series diverges, which means that I can't find a sum for that.
And that's going to do it for this video. Thanks for watching.